This lesson is going to be about isotopes. As you worked through the handout that I gave you in class, you noticed that boron had two different types of isotopes, or two different atoms. In some cases, boron had 5 neutrons, and in other cases, it had 6 neutrons. And if you were to average up the mass of all those neutrons, you were able to see that it miraculously became the atomic mass. And so isotope essentially is an atom that has different types of neutrons, but it still remains the same element. So for example, chlorine is a perfect example. Believe it or not, chlorine has 24 different types of isotopes. Sometimes it has an atomic mass of 28, which means that it only has 11 neutrons and 17 protons, and sometimes it has an atomic mass of 51, where it has 34 neutrons and only 17 protons. But keep in mind, chlorine will always have 17 protons. So these isotopes have a huge range of stability, and that means that some are much more stable and others are not stable at all and last for a fraction of a second. So they're practically non-existent. And chlorine happens to have 2 isotopes that are relatively stable. There's chlorine, excuse me, let me erase that. There you go. There's chlorine that has the atomic number, let's try that one more time. Chlorine that has an atomic number of 31, so we, 35. So we write it like this. And then you have chlorine that has the atomic number of 37. And when you see in nature the chlorine, it's about 75% of the chlorine has 17 protons and then 18 neutrons. In this case here, there's chlorine that has an atomic mass of 37, but it's only 22% of the time that you would see that. And in this case, it again has 17 protons. So you always know that it has 17 protons, because if it didn't, it wouldn't be chlorine. But in this case, it has 20 neutrons. So there's a difference between 18 and 20. And when you look at the atomic mass is an actual average of the two, which works out to be 35.45. So you can see that most of the time you have an atomic mass of 35, but that 22% is making this 0.45 happen. And so when you look at your periodic table and look at atomic masses, the reasons you don't have whole numbers is because those isotopes make those numbers be skewed a little bit. And that's simply all you need to know about isotopes.